Hi and welcome to Dr. St. Peter's SPSS tutorials. In today's demonstration, I'm going to show you how to conduct a repeated measures ANOVA or analysis of variance using SPSS. So first I'm going to go ahead and just make sure I have SPSS opened and pulled up. And I'm going to show you the scenario so you see where I get my numbers from. Okay, in the scenario I made for this, it says an industrial organizational psychologist wants to determine whether a new employee time management training program improves productivity. The same 10 employees complete the same productivity assessment at 3 time points: before training, 1 month after training, and 3 months after training. Productivity scores range from 0 to 100, with higher scores indicating greater productivity. Okay, so since we have the same people completing an assessment at more than 2 time points, a repeated measures ANOVA would be most appropriate. We have the data shown in this table. There are 10 people, so each row is a person. That's their before, 1 month, and 3 months in. So what we're going to do is we're just going to copy that data. I'm going to highlight it all, and I'm going to hit Control-C, or you can right-click and hit Copy. You're going to go into SPSS and paste. I like to do that just to minimize errors, but you could always just type them all in. Now we want to go ahead and name our variables. So this was data view. This is where we enter our data. So where it says data view is where you paste your data. Always make sure you're at the very top, number 1, very top. Now we want to go name those variables. So I'm going to go to variable view. And so what we're going to do here is we will just name each of those the different levels. So this would be before training, 1 month after training, and 3 months after training. Oops, 3 months. All right, make sure they're numeric. Sometimes when you paste them in, it changes it to string, and that would not work. You just tap over here, change it to numeric, and make sure that in your data view you still have numbers. I'll leave the width and decimals the same. We don't need to change the values, missing columns, align. The only other thing we could do here is maybe for measure, make them all scale. Okay, so if we go back to data view, you see my 3 different levels of our dependent or our independent variable, which is time. So again, they took that productivity at before training, 1 month, and 3 months after training. Okay, so the time is our independent variable. It is within subjects. We have these 3 levels, and each level is a column because that's how you enter within subjects information into SPSS. Now the numbers themselves are actually our dependent variable, the productivity. So now that we have this ready to go, we will be ready to analyze our data. So just to show you, I like to type it out and show you what I'm doing. We'll go to Analyze, General Linear Model, Repeated Measures. So we'll go to Analyze, General Linear Models, Repeated Measures, and then we need to name our factor. So that would be your independent variable, which I'm going to just put as time. Sorry, I already had done this, so I'm going to do it as time, and then 3 levels, and then you have to click Add. So this is just the name of my independent variable in this particular scenario. You could remove it, reset it, name it something else, but again, I think time is a good one, so don't forget to click Add. You'll see it down here. So our within subjects factor has 3 levels. Now we can click Define, and we just need to move our 3 columns over there. So you can do one at a time, or I just hold down my Shift key to press the very bottom, and then I can move them all over. Now over here for EM means, we'll need to select that. So within subjects ANOVAs, their post hocs are under EM means, not post hoc. So kind of counterintuitive, but go to EM means. And for time, we're going to want to compare main effects, and we'll just use the LSD with no interval adjustment. Click Continue. And then we want to go to Options and go ahead and click the first 3, which are Descriptive Statistics, Estimates of Effect Size, and Observed Power. And click Continue. Okay, we're ready to conduct our repeated measures ANOVA. So now we click OK. This tells us we have 3 different levels. And this is our means and standard deviations for the before, 1 month, and 3 months of productivity. We'll skip over the multivariate. Look at your Mauchly's test of sphericity and want to make sure that that SIG column is above 0.05. If not, you typically use one of these others. Greenhouse geyser is the next one I would recommend, and then whichever one would make it be above the 0.05. But we're good, so we don't have to do any modifications. So now we can go to our test of within subjects effects. This is our actual ANOVA output. This is what we're going to use to test our hypothesis and what we'll need to report the data. So we'll need to look at the sphericity assumed line because we didn't violate our assumption. That was at Mauchly's test of sphericity above. So we can read the top line for time, the top line for error. That's where we're going to get our degrees of freedom. So it'll be 2 and 18. And then we'll need to report our F value, which will be 8.90. Our sig value, which is 0.002. And then our effect size, which will be 0.497. I'm just going to go ahead and quickly highlight those so that when you see my write-up, you're going to see where I'm getting those numbers from. So you always have to report your degrees of freedom, your alpha value, and your effect size. Okay, so that's what we're doing. And we're reading those lines again because sphericity is assumed. And we got that from our Mauchly's test of sphericity. It was non-significant. Okay, so that's what we need for the write-up, but it is significant. This sig column is below 0.05, so that means that the overall test is significant. But the overall, or the omnibus ANOVA, is significant. While super exciting, yay, we get to reject our null hypothesis, we don't know which comparisons are significant. It could be between the before training and 1 month, the before training and 3 months, or it could even be between 1 and 3 months. So what we have to do is scroll down to where you see the estimated marginal means, and now we're going to get to our pairwise comparisons. This is our post hoc, so where it says pairwise comparisons. And what you want to do is it's looking at time 1 versus 2, and time 1 versus 3, and it gives you different p-values for each one. Now they're duplicates, right? So you have 1 and 2, and then here you have 2 and 1. So just to look for the ones that are less than 0.05 and see which ones are. And it looks like the only one that's less than 0.05 is a comparison between the time 1 and the time 2, which is baseline or before training, and then that 1 month. That's the only one that's significant. None of the other ones are significant. So that means that that training program that they did temporarily improved productivity, but not by month 3. Now you could get a larger sample size if you think there was a power issue, but given these results, we're going to write what we're given to just illustrate what this would be like. So I'm going to show you again our highlighted, but before I show you my write-up, I'm going to go ahead and do a figure because I always do a call out to the figure to show where those differences lie, as well as providing your post hocs. So for this, we're going to do a box plot because it's within subjects. So I'll go to graphs, and I want to do a box plot. We'll do simple, but we want to do summaries of separate variables, not because they're separate variables, but because you do enter each level as a separate variable in SPSS. Click define. We have our 3 levels right here. So if you have other variables, only select your 3 or your levels of your independent variable and put them into the boxes represent. If you accidentally select one or the other, you can just click on one, move it back and forth. Okay, once you have your 3 levels, if that's how many you have, you click OK. And this is the start of a figure, but it's not an APA format. I need to add a y-axis title and get rid of my grid lines. So I'm going to double click on it to open my chart editor. And then I'm going to double click on my y-axis so I can add, I'm going to go to labels and ticks and display axis title. Okay, so apply and close. And I want to go to options, hide grid lines. And then I just want to change my axis label here. This would be productivity. See how it's bolded, though it shouldn't be. So I'm just single click on it again and click the B up here to unbold it. And then down here I have before, 1 month, and 3 months. I like that. So I'm going to click X to get out of chart editor. And then I have to go back into my output, and there is a perfectly formatted figure. So I'm going to copy it as an image so I can paste it into a Word document. And that way you have a perfectly formatted note. Okay, so let's go up to how we would write this up. It says a one-way repeated measures ANOVA was conducted to examine whether a new employee time management training program improves productivity. Productivity was measured before training, 1 month post-training, and 3 months post-training. The null hypothesis was rejected. There is a difference. All right, so here's our statistical notation, and we got those numbers from where it says test of within subjects effects. So you see the F, and then you got your degrees of freedom 2 and 18 from right over here. And then you have your actual F value. I round everything to 2 decimals except for your sig column. You always report all 3 decimals there. And then our effect size rounded would be 0.50. Okay, then it says because this is less than 0.05, we must go on. If this was above 0.05, we would just leave it there because it would be non-significant. But because it's significant, we need to say post hoc. You do not write about post hocs if your p-value is above 0.05. But ours is below, so we're going to continue. Post hoc pairwise comparisons revealed that training only temporarily improved productivity at the 1 month mark. No other comparison was significant. Okay, where did I get this value from? This would be from our pairwise, our estimated marginal means, pairwise comparisons. So that's where the 1 versus the 2 was significant, the 2 versus the 1 was significant, but nothing else in that sig column is below 0.01. So time 1 was baseline or before training, and time 2 was 1 month. So that's where we got that right up. All right, and then we have see figure 1 as a call out. So what we can see here, I type in the word figure 1, I type in my title, case title for my figure 1, I paste in my figure from SPSS, and then I write a note below it. And the word note is italicized, but nothing else is. And there you have how to conduct and present a repeated measures ANOVA in SPSS. Thanks for watching.